In this lesson, we're going to learn about how current behaves in a circuit, and we're going to learn about Kirchhoff's law as well. Kirchhoff's law can be represented by our water analogy again. So as the water reaches this point in the river, what do you think happens to it? Some of the water goes down one branch, and some of the water goes down the other branch. The water splits down each branch, and at the end, it's added together. We call these points junctions. It's exactly the same in a river as it is in a circuit. Let's take a look at this simple circuit and see how Kirchhoff's law applies. In this circuit, we have a battery over here. We have two ammeters here and here, a bulb over here, and a switch as well. Let's turn the circuit on and see what happens. So we turned the circuit on by closing the switch. And at that point, current began to flow through the circuit. And that's what we can see here. We can see the electrons flowing through the circuit. Now this number here means that we have 4 coulombs of charge flowing through this ammeter every single second. We have 4 coulombs of charge flowing through it every single second. We have 4 coulombs, and that number is the same over here, over here, over here, through this bulb, and through this switch as well. It's the same amount of charge flowing through the circuit at every single point. What do you think would happen if we added a junction? If we added a junction over here, what would happen to this current? Let's take a look. This circuit is very similar to the one we looked at before. The only difference is we've added a junction in here and one here as well. So now the current has 2 paths to go down, this one and this one as well. When we close this circuit and we close this switch, what do you think is going to happen? Is it going to be the same as before or different? Let's take a look. So in this case, we can see a difference. We can see that as the current reaches this junction, it splits off into this direction and this direction. And interestingly, we have 2 amps here flowing through this path and 2 amps flowing through this path. You can also see that the current recollects at this junction here. So 2 amps plus 2 amps will give us 4 amps in this section. Let's try one more. This circuit here is slightly different. Let's switch it on and see what happens. You should be able to see that the current is far smaller in this path than it is in this path. We only have 1 amp of current here, whereas we have 4 amps of current here. This means that the rate of flow of charge, essentially how much charge is flowing through this path, is 4 times greater than this path. Now, I want you to think, if I was to add an ammeter here, what number would I get? Pause the video, think, and let's have a go. Let's close this circuit and see what happens. We have 5 amps. How do we get that? 1 amp plus 4 amps gives us 5 amps. Let's try a few more calculations now. What we just saw is a great example of Kirchhoff's law. This states that the sum of the currents splitting at any junction is equal to the sum of the currents that entered it. Let's take a look at what that means. Really, it's what goes in must come out. So, the sum of the currents splitting at any junction, so we can imagine currents splitting in this direction and this direction. Let's call this A and B, is always equal to the sum of the currents that have entered it. So we can call this C. And we can state that C is equal to A plus B. These two currents are equal when added up to this value. Let's try a few examples. Use Kirchhoff's law to find this missing current leaving the junction. So we know that the current entering is 5 amps, and that's equal to 2 amps plus an unknown number. So the value is simply 3 amps. Have a go yourself first and pause the video. So in this case, 4 amps plus an unknown I is equal to 9 amps. Remember, these two paths are equal to this one. What goes in must come out. So in this case, our value for I is equal to 5 amps. Let's have a go at another. This one is slightly more complicated. Pause the video and have a go. So, in this case, the current going in is 4 amps here and 3 amps here. And the current coming out is 6 amps here and an unknown value W here. So we can write that as 4 amps plus 3 amps is equal to 6 amps plus W. We can simply rearrange this to find that W is equal to 1 amp. And that's it. I hope this has been useful. If you have any questions, please do ask.